Welcome to the notes for H4-8, Solving Systems of Equations and Inequalities. So our objective here for this lesson, students will use their knowledge of solving equations and inequalities by graphing to solve systems of inequalities graphically. So we're trying to solve some inequalities using the graph instead of doing the algebra that we've been doing the past couple lessons. So letter A says solve the equation by graphing. So this is just a little review problem here, looking at some of the methods that we can use for solving equations using graphs. With this method here, I am going to just review the method for breaking this equation into two equations and then treating each of them as a function and graphing them as a system. So we're going to take the left side of the equation. We're going to set it equal to y. So we have y is equal to the quantity of x plus 1 squared plus 3. And then our right side would be y is equal to x plus 6. We're going to take each of these and graph them on our coordinate plane. So this first one here is a parabola, and our vertex, our locator point here, should be located at -1, 3. And then it looks like we have just standard growth on this one. So let's put our vertex on there at -1, 3. And then we know it has standard growth. It's going to go over 1 and up 1, over 2 and up 4. And we can reflect that here. And it looks like that's probably the main points that are going to fit. So we're going to take it here and just graph that parabola. Now the second equation is a line, and we know that our slope is 1 and the y-intercept is 6. So we'll plot that y-intercept first. And since the slope is 1, we're going to rise 1 and run 1. So you can plot as many of those points as you need to in order to be able to graph the line. So I'm going to sketch that on here. And after we've graphed that one, I'm going to emphasize here that we've got a point here and a point here that we would consider to be intersection points. So I'll try to highlight those for you. And the points that those are located at, we have -2, 4. And the second one appears to be 1, 7. Now remember, our original equation here had just x coordinates, right? So when we're solving it, we're only looking for the x values. So our solution to the equation will be found in the x coordinates of the intersection points. So we will say here that x equals -2, or x is going to equal +1. Those are the solutions to this equation. Letter B here, I think we're going to skip over this one. This one's almost identical to the last problem. We're just graphing a parabola and a line and then looking for the intersection. If you want to try it, and then you can ask in class, and I'll let you know if you got it right or wrong. Or better yet, you can check it to see if you get it right or wrong after you do it. Let's move along here. Letter C, now this one's different. Okay, so it says solve the system of equations by graphing. So notice now we have two equations. They each have an x and a y in them. So what we're going to be looking for on this one are actual points. Okay, so we want the points where the two graphs will intersect. For the first one there, the y equals x squared plus 6x plus 5, you can graph that any way you know how. I would suggest to you maybe going ahead there and practicing completing the square, right? Make sure you subtract your c term from each side. And then look to complete the square. We have y minus 5 plus blank is equal to x squared plus 6x plus blank. And we know that we take this middle number here, we divide it by 2 and square it. So when you do that, when you take 6 divided by 2 and then you square that number, that would equal 9. So we're going to have to add 9 to the right side and the left side of the equation. So now we're looking at y plus 4 is equal to, and we can take this trinomial and we can factor it into the quantity of x plus 3 squared, which leaves us with a parabola looking like this now in its graphing form. y is equal to the quantity of x plus 3 squared minus 4. So our vertex is going to be -3, -4. We can go ahead and plot that on here. It's got standard growth, so you're going to go over 1 and up 1, over 2 and up 4. So that looks like you're going to cross the x-axis at -1 and -5. And if you want to go another one, you probably could here. If we go to 3 to the right, we'll go up 9, up to the point 0.05, and then -6.5 there. And then we'll just go ahead and connect those points. And now that we've done that here, we'll go ahead here and look to see if we can graph our second function. I'm going to make that one blue. Y is equal to -x minus 1. So our slope in this case here is -1, and our y-intercept is -1. So we'll put our -1 on the y-axis, and then we're going to go up 1, but then back 1. Remember, this line should go down to the right because it has a negative slope. So after you get enough points on there, you can go ahead there and connect them to draw in your line. And it looks like the intersection points you end up with here are at the point -6.5 and at the point -1, 0. Now with this one here, since we are looking for x and y coordinates, right, that means that these are actually going to be our solutions. We're not worrying about just the x like we did in the last problem. If you take each of those values and you plug them in, you will see that it will make each of those statements true. For time's sake, I'm not going to do that right here at the moment. I know that you know how to do that, so I'm going to move on so I can, make this video, short as possible. Letter D. Now we're going to look at solving a system of inequalities by graphing. So first thing here, let's just kind of review. I think you may have done a little bit of this in Algebra 1, but to be sure, we'll just talk about it right now. When we're graphing lines on a coordinate plane, or any shape on a coordinate plane there, remember, our lines will be solid if we're looking at greater than or equal to, less than or equal to, or just plain equal to. Our lines are dashed if it's greater than or just less than. And then we look to shade above or below our lines, right? We look to shade above or below our lines depending on if they're greater than or less than. And we'll talk about that here as we go into graphing a few of these. So the first one we're looking at here, we'll graph the y is greater than or equal to the quantity of x plus 5 squared minus 3. And then the second one is a line, y is less than 1/2 x plus 5. So for our parabola, we have the locator point would be at -5, -3. We'll plot that on there. It's got standard growth, so you can go ahead and plot the points as you need to. And then when I graph this one, right, I know this is all the y values that are greater than or equal to. So since it's equal to, we're going to need to take that and we're going to need to make this one a solid line, or a solid curve, I should say, since this one actually isn't a line. Okay, now we're looking for a region where all of the values or all the points on the coordinate plane will make it true. So what we've got here, our graph is like a boundary point. So if I wanted to figure out all of the points that make this true, since I'm looking for the y values that are greater than this parabola, right? So the parabola is exactly where we see it here. Actually, I'm going to highlight it here. This is the actual parabola, right? So we're looking at it here. This is the parabola. And we're looking for all the y coordinates that are greater than the parabola, or all the outputs there. So looking at that, right, if you put your pencil on the parabola and then just go straight up, that will take you to the greater side. But if you're not sure about that, let's just do something similar to what you did in one of the previous lessons there, and just choose a point and plug it in to make sure it makes it true. If it's me, I'm going to check with the point here. Let's say this looks like -6, I'm going to check to see if that's true. If it's not, I'm going to choose a point from outside of the parabola to see if it makes it true. So here's my check on the left side. I'm going to say this was the point -6, 0. So I'm going to put in 0 for y. 0 is greater than or equal to -6 plus 5 squared minus 3. When you simplify that, you get 1 minus 3, which is -2, and that is less than or equal to 0, or 0 is greater than or equal to -2. So that is correct there, which means that the area that we would shade in would have to end up being inside of this parabola. So these are all the values that if we took the x and y coordinates and plugged them into the inequality, it would make it true. Now we need to focus on our second graph. We have y is less than 1/2 x plus 5. Well, we know our slope is 1/2 and the y-intercept is 5. So we'll put our point at 5. And then we rise 1 and run 2, rise 1 and run 2, and so on, or go down 1 and back 2. Now that one is going to be a dashed line, so we'll go ahead there and dash that one. And because we're looking for all the y values that are less than this, right? This is that line here. Looking for all the y values that are less than that line. Well, that would represent, the region that's like beneath it there, right? Everything that's less is going to be below when we're talking about outputs. So let's choose a point. An easy point that I like to use here would be the point like 0, 0. If I check that graph using 0, 0 to see if it's true, that'll let me know if I need to shade on this side or the side above it. So 0 is less than 1/2 times 0 plus 5. And you see there, that is a true statement. So with that one, we would end up shading everything beneath the line. And yes, it's okay to, to shade over your parabola. Now, if you're scribbling and making everything super, super dark, that may cause more problems for you. Like I said, this should be a review skill, so we should know that not to, mark it so dark that you can't see your other graphs. Our region here where everything comes together actually ends up being inside of the parabola, but beneath the line. So here is where our solution region is. Actually, let me use a color here that you can see. How about orange? This is going to be our solution region. And we can take any value out of there and plug it in to make sure that it makes both of the inequalities true. So you may want to you could use that point -6, 0 again. You already know it works in this one. You can plug -6, 0 into the other one there, and you'll see that it makes it true. So our solution is this orange region that we've shaded in on the graph. All right, let's move on to the next one. Solve the system of inequalities by graphing. So same kind of thing. We've got this one, and I think there's one more after this. So if you want to pause it and try to see if you can work it out correctly, please go for it there. So the first function we'll be looking at here, this is our parabola. We're looking at y is less than x squared minus 4. So our locator point is at 0, -4, and it's got standard growth. And this one's going to be a dashed line. And since we're looking for all the y values that are less than this line, right, put your pencil on the vertex. If it's less than the line, go down, right? That would be the side that's less. You can check it there by choosing a point. I'm going to choose a point from down here. Let's say that 0, -8 down here. Let's plug that in to make sure that we are on the correct side. So we have -8 is less than 0 squared minus 4. And you see that -8 is less than -4, which is correct. So we would end up shading outside of here. And you don't have to shade at all. You can wait to the very end to shade if you want to. I'm just going to do a nice little shade here so that I can still read my graph and see the points that are on it. So those are all the values that are less than that parabola. And now we're going to look at the line, the second one there. We've got, do that one in red. So for that one here, our slope is -3/4, and our y-intercept is 3. So we'll go down 3 and right 4, or up 3 and back 4. That one will be solid, right, because it has the equal sign in it. Just take it there and connect them like that. Now you're looking for which side to shade on. Well, put your pencil on it. And if you move your pencil up, that would be the greater side, right? So this side here should be the greater side. Choose a point, plug it in to check it. Let's see here. Let's use something that's divisible by 4 if we're smart and want to make it easy on ourselves. So let's just say like the point 0.8. Let's try the point 0.8. So we're going to check with 0.8. So 8 is greater than or equal to -3/4 times 0, right? 0 will make this easier for us because it's going to cancel out that fraction, plus 3. And you see here we get 8 is greater than or equal to 3, which is a true statement. So that means if we were to shade for this one here, we'd be shading everything above the line. So now all we have to do is look for where is the overlapping region where we've shaded both of the graphs. And you'll see that there are 2 of them. There's this region here. So everything above the line and outside the parabola. And then there's a region over here. This region on the right side and that region on the left side are what make up the entire solution to this problem. So if you want to take a point out of there and plug it in for the x and the y in either of the inequalities, it should make them true. So I'm going to hold off on doing that here. I'm going to let you can do it if you'd like to, but I want to make sure that I get through these notes as quickly as possible. All right, let's try the last one. Last one we have here is a line and an absolute value inequality. So first we'll do the line. We've got y is less than or equal to -2x minus 3. Slope is -2. Y-intercept is -3. So up 2 and back 1. Or down 2 and right 1. We'll take that there and make it solid. Which side would we need to shade on? Well, the side that's less, right? So put your pencil on, where it's equal to it there, and then go down. So this would be the side that we would shade on for the line. Y is less than or equal to -2x minus 3. And then we're going to take it here and we're going to do our absolute value function here. Y is greater than x plus 6, and the absolute value is minus 2. Locator point, -6, -2, and then it has standard growth for an absolute value function. So rise 1 and run 1. And this one's going to be just a dashed graph. All right, and then on that one it says we're looking for everything that's greater than that graph there, all the outputs that are greater. So put your pencil on the vertex, and if you go straight up, that would be the side that I would consider to be greater. You can check it by plugging in a point on that one there. Since we didn't do it on the other one, I'll definitely check it on this one to show you. This is the point -6, 0. If I put in my checkpoint as -6, 0 on that one, you'll see here that we've got 0 is greater than the absolute value of -6 plus 6 minus 2, which should give us 0 is greater than -2. That is a true statement, which means we can shade everything above the absolute value, or everything inside the V, we could say. So where's the solution region? Well, that's going to be all of our points right inside of here. And now you can take that point there and you can plug them back in to check to make sure it makes both inequalities true. If not, we may have an issue. So the green region is our solution region there. So you know what, let's just go ahead and throw one in there just to check it. It just so happens that point we just used, the -6, 0, we already knew it worked inside of our absolute value. So let's just plug that into the other equation for our line. So we'll check this here by saying 0 is less than or equal to -2 times -6 minus 3. Well, that should give us 9, and 0 is less than or equal to 9, so we know that we are correct. All right, that's the notes for H4-8. Hopefully this one wasn't too long for you there, but it did make some sense. If you have questions, make sure you bring them to class. It's your responsibility to ask if you have them.